Yeah.
Ever found yourself staring at your critical tech infrastructure and just wondering, what if this all just vanished?
Mm,
We're talking about the backbone,
yeah.
the stuff you absolutely rely on.
Oh, yeah. That's the question that keeps anyone responsible for uptime, well, up at night. Planning for the unexpected is just paramount.
And that's exactly where we're focusing our deep dive today,
Hmm.
making your Proxmox setup really, truly resilient against disasters.
Mm.
Specifically, thinking about those dreaded data center outages.
Mm-hmm.
You shared some really insightful material, particularly an article talking through strategies for disaster-proofing a Proxmox environment.
Yeah, being proactive here is just crucial.
Yeah.
Downtime costs, well, it can cost a lot. So robust planning isn't just nice to have, it's a necessary investment.
So our mission today is basically to navigate through these strategies and figure out the most effective and, let's be honest, probably the least stressful way to make sure your Proxmox setup can handle a major disruption. And what's fascinating, I think, is seeing how the consensus in the tech community seems to be shifting. There's this clear pivot away from trying to stretch Ceph over long distances, moving towards a more maybe pragmatic approach, like ZFS replication.
Absolutely. That evolution really reflects real-world experience, doesn't it? And a deeper grasp of the strengths and maybe the limitations of these technologies in different situations.
Okay, let's unpack the initial challenge then. Picture this. You've built a solid 6-node Proxmox cluster. Nice and balanced, 3 nodes humming away in one data center, the other 3 in a totally separate location.
Geographically separate, yeah.
And you've even invested in good, fast network links between them, say 25 gig. Seems pretty resilient on the surface, right?
On paper, definitely. It looks like you've got redundancy, distributed resources. Those high-speed links suggest good communication pathways are there.
But then the big question, the one I know would be bugging me, and probably you too. What happens if one of those data centers suddenly goes dark? Just poof, gone.
Yeah, half your compute power just vanished.
Exactly. And the immediate worry is, how do you keep your storage accessible? How do you make sure those critical services keep running without, a major hiccup?
That really is the core of business continuity when you've got multiple sites. You need to minimize disruption, keep data available. That's the goal when one location takes a major hit.
Now, for many people tackling this for the first time, the initial thought might be, hey, why don't I just stretch a Ceph cluster across both sites? It sounds logical, one big unified storage pool spanning both locations.
Yeah, the idea of a single consistent storage layer across sites, it definitely has an appeal. Seems simpler to manage, maybe.
But, and this is a big but, this is where the online community, the folks who've actually tried this stuff, they start waving some pretty big warning flags.
Mm-hmm.
Turns out Ceph's architecture isn't really optimized for the kind of higher latency links you usually get between separate data centers.
Precisely. Ceph really depends, heavily depends, on consistent, low-latency communication between all its nodes. If you introduce significant network delay, well, you can get a whole cascade of issues.
The article we looked at even quotes someone saying it very directly.
Right.
Ceph is not meant to be used over higher latency links. Plain and simple.
It's true.
And I thought the analogy they used was spot on.
Yeah.
Trying to make Ceph work well stretched across distance. It's like putting a Formula One car on a muddy dirt track.
Huh. Yeah, that's a good one.
It might technically move, but it's going to be slow, inefficient, and probably end up broken down in a ditch. So the core takeaway here is, unless you're maybe a massive telco with your own private fiber everywhere, stretching Ceph is generally just asking for trouble.
That comparison really hits the nail on the head. The fundamental design assumes high bandwidth, low latency. If you don't have that, the system can just behave unpredictably. Badly, even. The community experience really backs that up.
Okay, so if stretching Ceph across data centers is, let's say, generally a bad idea for most of us, what's the more stable, less chaotic solution? The one the community seems to be leaning towards more and more.
That would be ZFS replication.
Ah, ZFS.
Exactly. ZFS, the zettabyte file system, it's got a really solid reputation, great for data integrity, overall robustness. It's known for being adaptable, resilient in all sorts of storage situations.
And the crucial difference that was highlighted is how ZFS handles syncing data compared to Ceph. Ceph needs that constant real-time chat between nodes, which, like we said, hates latency. But ZFS replication is asynchronous.
Yeah.
Can you break that down a bit?
Sure. Asynchronous replication basically means ZFS takes these point-in-time snapshots of your data. Think of them like pictures. It takes these snapshots at set times, maybe every hour, maybe every 15 minutes.
Right.
And then it sends those snapshots over to the other site. It's not trying to mirror every single write block by block as it happens.
Okay, so it's less like a live video feed that needs perfect sync and more like sending photos periodically.
Exactly. You take a picture, send the picture, take another picture later, send the changes since the last one.
That makes a ton of sense for reducing network stress, especially over distance. And the article mentioned another commenter just saying flat out, ZFS replication is very easy in comparison.
And that simplicity is huge, both for setting it up initially and just managing it day to day. It tends to be way less complex, less likely to run into those tricky network problems you can get with stretched Ceph.
So it's really about using the right tool for this specific job. And for multi-site disaster recovery with typical network latency, ZFS replication just seems like a much better fit.
That's the core insight, yes. You leverage ZFS's snapshotting and that asynchronous nature, and you basically sidestep the big problems that plague stretched Ceph over a WAN.
The article then gets into some of the key advantages of this ZFS approach. First off, snapshots. Apparently, ZFS snapshots are incredibly lightweight and fast.
Oh yeah, that's a core ZFS strength. They mainly work with metadata, so they're super efficient, hardly any performance hit. And that efficiency means you can take them really often, which is key for minimizing potential data loss if something goes wrong.
Makes sense. Then there's the easy replication part. Instead of that constant live mirroring, you're just sending the changes since the last snapshot at regular intervals. That sounds like it would dramatically cut down the strain on the network links between your sites.
Precisely. You're only sending the delta, the difference. That drastically cuts bandwidth needs and makes it much less sensitive to network latency fluctuations. Makes reliable replication over distance actually feasible for most people.
And the big payoff, obviously, is being disaster ready.
Yeah.
If data center A goes offline, data center B has a nearly up-to-date copy of your data, basically ready to be spun up.
That's the whole point of DR, right? To have a functional, current copy of your critical stuff available somewhere else so you can recover quickly with minimal data loss.
The article also brought up a smart architectural point, having shared ZFS at each DC and replicate between sites.
Right.
So you're not trying to stretch one giant ZFS pool across the country.
Right.
You have independent ZFS pools locally, and they just replicate to each other. That seems to directly tackle the latency problem we keep coming back to.
That's the key design pattern. Local storage at each site for performance and reliability, and then use replication purely for the DR aspect. It avoids the bottlenecks and risks of trying to stretch storage tech over high latency networks.
It's interesting, the article also quickly mentions some other ideas people have kicked around, like splitting Ceph pools, one pool per DC, then manually replicating VM disk images. That sounds
It does give you some isolation, avoids the immediate stretched cluster issues, but yeah. The manual steps, the potential for things getting out of sync. It adds its own layer of complexity and risk, probably hard to manage well, especially at scale.
They also talked about using dual Proxmox backup servers, one at each site, doing local backups, then copying those backups across. Sounds like a solid backup plan, good for point-in-time recovery.
Definitely a solid backup strategy.
But it's more about restoring from a backup, not immediate live failover, right? The recovery time would likely be longer.
Correct. Robust backups are absolutely essential, a cornerstone of any DR plan, but they usually mean a longer recovery time objective RTO compared to replication, where you have a much hotter, more ready-to-go copy of the data.
And then there was application layer high availability, making things like databases redundant within the application itself. That can be good for specific critical apps.
Very valuable in certain cases, yes.
But it's not a blanket solution for all your storage across the board.
Exactly. App-level HA solves availability for that service, but it doesn't give you general resilience for all your underlying storage, for all your VMs and data.
But the article did suggest, and this makes sense, that maybe the most robust strategy is actually layering these things. Use ZFS replication for that near real-time DR capability. Use Proxmox backup server for those comprehensive offline backups just in case.
Absolutely.
And maybe use application-level HA for your absolute Tier 1 critical services. That sounds like a pretty well-rounded built-in-suspenders approach.
Yeah, a layered approach to resilience is generally seen as the most effective. You're addressing different aspects of data protection and recovery with tools that complement each other.
Now, let's loop back to Ceph for a second, because the article really hammered home this big red flag around something called Ceph stretch mode. Apparently, there's a technical way to stretch Ceph across sites, but the requirements sound kind of insane.
They are, generally speaking, extraordinarily demanding and pretty impractical for most people. Stretch mode is really designed for Very specific scenarios think environments with extremely low latency and exceptionally high bandwidth between all the sites involved.
Yeah, like you need full copies of all your data at each site. Okay, that makes sense for redundancy.
hmm
But then you also need a third, completely separate site just to host a tiebreaker monitor.
Yep. That third site is critical.
That's to prevent split brain, right? Where the two main sites lose contact and the cluster gets confused about who has the real data. That third site requirement alone just sounds like a massive jump in complexity and cost.
That independent quorum monitor is absolutely essential in a stretched cluster. It maintains consensus, prevents data corruption if the network between the main sites gets partitioned. But yes, needing a geographically separate third location adds significant logistical and financial hurdles.
And the network demands. The article said you need insanely good network connections, like at least 25 gigabits per second, maybe more, between all three locations. That is not your average intersite link.
No, not at all. That level of dedicated low latency bandwidth is crucial for the synchronous or near synchronous replication Ceph needs. For most organizations, getting and maintaining those kinds of links between distant sites is just not really feasible.
And the article didn't mince words, quoting another commenter who just said, "Don't do it."
Laughs slightly, yeah, pretty blunt.
It really underlines the point. Stretching Ceph over significant distances, generally not worth the huge risk and complexity for the vast majority of users.
Unless you happen to have the very specific resources, the infrastructure, the deep expertise needed to meet those super strict requirements.
Yeah, trying to stretch Ceph long distance is definitely a high-risk game. The potential for things going badly wrong often outweighs any perceived benefit for most setups.
Okay, so ZFS replication is looking like the much more practical path for most of us. The article gave a nice high-level overview of how you'd actually set it up. Step 1, no surprise, is getting robust ZFS pools on each node, recommending RAID Z,
Which uses parity, saves space, but gives you redundancy.
or mirrors, which create an exact copy, better for read speed and maybe slightly faster rebuilds, depending on what you need. Right, you need that solid ZFS foundation first, well-configured, redundant storage. That's paramount before you even think about replication. RAID Z, mirrors, they have different trade-offs, capacity versus redundancy levels.
Then scheduling regular snapshots. The frequency here depends on your tolerance for data loss, right? Your RPO recovery point objective. Maybe snapshots every hour, maybe every 15 minutes, maybe just once a day.
Exactly. How much data are you willing to potentially lose if disaster strikes right before the next snapshot? That dictates your frequency. More often means less potential loss, but uses a bit more storage and processing.
And the article points out that Proxmox actually has a built-in replication tool. It handles transferring the VMs and containers between nodes using ZFS replication. That sounds super handy, very user-friendly.
Yeah, the integration within Proxmox itself is a big plus. It really streamlines setting up and managing ZFS replication, specifically for virtual machines and containers.
And then the step you absolutely, positively cannot skip, testing. Thoroughly testing your failover.
Oh, absolutely critical.
Actually simulating a DC failure, seeing how quickly and smoothly you can bring everything up at the secondary site.
You have to do it regularly, comprehensively. You need to validate the plan, make sure the replication actually works as you expect it to before a real disaster hits. Finding and fixing problems during testing is key.
And obviously keeping an eye on the replication logs. Just making sure snapshots are happening, transfers are completing successfully. Basic sysadmin hygiene, really.
Continuous monitoring is fundamental for any critical system. Checking those logs lets you spot and fix potential issues proactively.
And the article looped back again to adding Proxmox backup server into the mix for those complete offline backups, just as an extra safety net.
Yeah, PBS provides a really valuable extra layer of defense. Protects against things replication might not, like accidental deletions or maybe some kind of data corruption that could get replicated. It complements ZFS replication very nicely.
What I find really cool looking at the bigger picture here is how technologies like Proxmox and ZFS are, well, they're kind of democratizing enterprise-level resilience, aren't they?
They really are.
Stuff that used to be only for massive corporations with huge budgets. Now it's becoming accessible for smaller businesses, even serious home lab folks.
It's a great example of how technology, especially in the open source world, is empowering a much wider range of people to build really robust, reliable infrastructure.
And the article gave a nice shout out to the online community too, how helpful and collaborative people are, even if you're asking basic questions. That's such a huge plus with open source.
Absolutely. That vibrant, helpful community is an incredible resource. People sharing knowledge, helping others learn, it's a massive asset.
So the key takeaway really feels like this. If you make that informed choice, go with smart ZFS replication. Instead of wrestling with the risks and complexities of stretched Ceph, you're not just prepping for the worst case, you're actually building a more stable, more manageable, and ultimately more resilient Proxmox setup for the long run.
It boils down to understanding the tools, right? Knowing the strengths, the weaknesses, and picking the solution that fits your actual situation, your infrastructure, your team's expertise, your tolerance for risk.
Build smart, build resilient.
Mhm.
Sounds like a good mantra. So hopefully you listening now have a much clearer picture of a more effective way to handle disaster recovery for Proxmox using ZFS replication. And it really makes you think, doesn't it? Considering how much we rely on all this digital infrastructure now,
Mm.
what other sort of long-standing tried and true methods in tech might be due for a serious rethink? In light of newer, maybe more efficient, more resilient technologies come along, it's bigger than just Proxmox, really. It's about constantly questioning, constantly adapting our strategies for a more robust future.